Okay, we're going to be taking the notes for day 5 of this unit, more graphing with sine. We have a couple of vocabulary words that I want to go over first before we jump into notes. In the top right corner of your sheet, you could please write down the following equation. Y is equal to A sine B times X plus D. The letter B is going to be replaced with a number, and that number is the frequency of the graph. The frequency, definition of frequency, is the number of cycles completed within 0 to 2 pi or any other 360-degree interval. It doesn't necessarily have to be 0 to 2 pi, but traditionally we use the 0 to 2 pi. But pretty much within any 360-degree interval, that's going to give us how many complete cycles we're going to see. We need to know how long it takes for one complete cycle to occur, and that's called period. So the definition of period is the length it takes for one cycle to complete. And we get period by a really small formula from, and we will use information from our equation. And to calculate period, you take 2 pi and divide it by the b value, which is the frequency. And we'll get the frequency from the equation. We have a couple of questions that we're going to practice finding period, and then we're going to actually graph with a change in frequency that will change our graph. So for these, I'm going to also ask you to write down the amplitude, just kind of we get into the habit of starting from the beginning, writing the amplitude, and then the period, and then whatever shifts happen after that. The amplitude of this one, don't remember, it is the number that's out in front. The amplitude is 1. And since frequency is equal to 2, period is 2 pi divided by 2, which is pi. And we'll talk about that just in a couple of examples, how that changes the graph. So period is pi for number 1. In number 2, the amplitude is 4. The frequency is 1. It's the number that's right in front of the x. It's an invisible 1. So period will be 2 pi divided by 1. So period is 2 pi. In number 3, the amplitude is 6. Notice that the frequency, the b value, is a 1/2. So you have to be a little bit more careful when we're calculating period here. It's 2 pi divided by 1/2. And remember, we do a keep, change, flip. When we're dividing fractions, we'll keep the first fraction, change division to multiplication, flip the second fraction. So period here is 4 pi. That means that this person is driving really, really, really slowly. It's taking twice as long to get to where they need to go because their speed is 1/2 of what the speed is of the parent function. So instead of taking only 2 pi to get to where they need to go, it's taking all the way up to 4 pi to get to their destination. Whereas in the first one, if you compare it to the first one, the frequency is 2. So that means this person is talking really, really fast or driving much faster, twice as fast, so it takes them less time to get all the information. It takes them less time to get to the destination. And the last one, there's a whole bunch of numbers here, and you really have to be careful. You know exactly what number represents what. The amplitude is 2, meaning how high from the midline. We'll talk about that in a few minutes. The frequency is 4. This person is driving really, really, really fast, or talking 4 times as fast as the parent function does. So period, and again, it's 2 pi divided by b, so it's 2 pi divided by 4. Period here is pi divided by 2. Again, period is the amount of time it takes for a complete cycle to occur. So how does that change our graph? The graph is still going to look just like a sine graph. What's going to basically change is the x-axis. The values on the x-axis, the angles. Okay, so in this example, we're going to graph g of x, which is sine of 2x. Again, we're going to write down what we know. We know the amplitude is 1. The frequency is 2. Period will be 2 pi divided by 2, which is pi. So what I do with that, if I'm not given a specific interval of where I need to graph, what I'm going to do is I'm going to take pi, because it's my period, I'm going to go all the way over here. I'm going to put it right at the end of my x-axis because that's going to give me the entire curve. And then I'm going to go backwards, take half of pi, which is pi over 2, half of pi over 2, which is pi over 4, and then the number in the middle, 3 pi over 4, what's between 90 and 180, and that's that 135. The other way you can get those points is called key points, something that I'll do every once in a while. Key points is you're going to take your period and divide it by 4. So notice I have pi over 4. Key points means something important happens, something critical happens. Remember, sine starts at 0, goes high, 0, low, 0. So every 45 degrees, something's going to happen. It's going to start at 0. The next 45, it's going to hit a high. The next 45, it's going to hit a low. Or I'm sorry, it's going to hit 0. The next 45, it's going to hit a low. And then the last 45 is going to be back up to 0. So basically what we're doing is dividing into those 4 quarters. Amplitude is 1, so I can rescale my y-axis and put 1 and -1 on the y-axis that way. And then plot my points, again, using OHOLO. And again, every 45 degrees something happens. It's a sine curve, so we're starting at 0. At 45, I'm going to hit the high. At the next 45, which is 90, I'm going to be back at 0, my shoreline. At the next 45, I'm going to hit the low. And then the last 45, I'm going to be back at 0 where I started. And when you connect your dots, don't forget, it's a smooth curve, no points. They're kind of like two parabolas kind of stuck together. We have a smooth curve like that for the sine curve. Today we're going to concentrate on sine. The next lesson is going to concentrate on cosine. So we're just going to concentrate on sine today with change in the frequency, which is going to change period, which is pretty much going to change our x-axis, how we label the x-axis. Feel free to pause this video anytime you need to catch up or rewind it and play it again. I will also give you other links at the on Classroom to give you other places to go to find more information. Okay, h of x is equal to sine of 1/2 x. So this person is driving much slower. It's going to take longer in order to get for the entire curve. The amplitude is still 1. Frequency is 1/2. So that means period will be 2 pi divided by 1/2. And don't forget, keep change flip. Keep the first fraction the same. Change division to multiplication. Flip the second fraction, which is now going to be 2, 4 pi. Immediately take that 4 pi. And I'm moving over here, and I'm plotting 4 pi at the end of my x-axis. Then going backwards, cutting 4 pi in half, which is 2 pi. Half of 2 pi, 1 pi. The pi between 2 pi and 4 pi is 3 pi. Since my amplitude is only going up to 1 and -1, I can use my tick marks in that way so the graph is nicely spread out. Check out the key points. When I do the key points, I'll take the period and divide it by 4. Notice how the key points matches to the quarters that I labeled on the x-axis. So you're going to see those should match. Okay, so we're ready to plot our points. Don't forget, sine starts 0, goes high, has to hit 0 before it goes down to low, and then it's going to stop at 0. So we're at 0. At pi, we're going to hit the high. 2 pi, we're at 0. 3 pi at -1, and 4 pi when the curve is done, we're back at 0. And again, connect the dots. Notice how it is pretty much identical to the previous one. The big difference that you have to see, and it is a big difference, are the two x-axes, how they're scaled. So notice the second one is 1/2, so it takes a lot longer, whereas the first one, it's 1/2, or it's a 2x, so the period is pi, so the scale only goes up to pi. Okay, on the back. This time we're going to include a change in amplitude. This time we're going to include a change in amplitude. Amplitude is equal to 2. And period is going to be 2 pi divided by 2 because of the frequency here. So that's going to be pi. So we have somebody who's talking very, very loudly and talking twice as fast as the parent function. The key point, we'll take the period and divide it by 4. That gives you an idea of what the tick marks, what the hash marks are going to be labeled on the x-axis. So again, I'll take period, plot it at the end, and I can either take my key points, which is every 45 degrees, or I can cut pi in half and get pi over 2. But I do need to label. I do need to label the x-axis with the correct angles. And again, it's a sine curve, so I start 0, go high, 0, low, 0. Every 45 degrees, something significant happens. The range is going to be different than the range from the previous two examples. We are now going to be going from -2 to 2 because of the amplitude. So if I label my y-axis the way I labeled before, we're going to have a graph that's going to be just a little bit different from the previous ones. Again, since it's a sine, we're starting at the shoreline. At 45 degrees, we're going to hit our high, and since the amplitude is 2, the high is going to be at 2. Don't forget, we have to cross the 0 line before we get to low. 3 pi over 4, we hit the low of -2, and then we finish off at pi. Connect the dots with a smooth curve, and there you go. In the next section, we're going to add a vertical shift to our graph. Let's review what we know so far. The number out in front, which is the letter A, is the amplitude. This is the distance from the midline. The midline also can be referred to as the wrap line if you're looking at other videos. Wrap line. I also tend to call it the shoreline. So all those words mean the same thing from the midline. So amplitude is the distance. How far away are you is the high and the low from the midline. B, we just talked about that. This is the frequency. And again, the definition of frequency is how many cycles within any 360-degree interval. And what we're going to add to that is the vertical shift, which is a plus or minus d at the end. If it's a plus, we're going to go up. If it's a minus, we're going to go down. And the vertical shift is the new midline. Big idea for this section is when we shift the graph, the entire graph is either going to go up or down. The midline will no longer be the x-axis. The midline is going to be whatever the vertical shift is. So let's look at the first example, y is equal to sine x plus 1. And they're asking us to graph it from 0 to 2 pi. So that means I'm immediately going to put 2 pi at the end. And I can scale my x-axis accordingly with my quadrantals. I'm going to change the way I scale my y-axis. I'm going to put 1, 2, and 3 every tick mark instead of every other one, like I did for the previous examples. And let's pick apart this equation. Amplitude is 1. The frequency is 1, so we're not changing anything with frequency. Period is still going to be 2 pi, just like in our parent function. What we have now is a vertical shift of up 1. So that means that we don't normally graph this part. We do it lightly. If you're using a pencil, like we should be using, it's a very lightly dashed line that's going to be our new midline. And we put it in there to help us get the middle of the graph. So that's our new midline. Which is y is equal to 1. So that means now we're counting from the midline, from this midline, how high and how low for the amplitude. And the range, before the vertical shift, based on the amplitude, is from -1 to 1. But because we went up 1, because of the vertical shift, our range, our graph will only exist from 0 to 2, where 0 is the minimum and 2 is the maximum y value. So 0 is the minimum, and 2 is the maximum. And we'll keep that in mind as we're plotting our points and making our graph. It's a sine curve. We start at 0. Our new 0 is at the shoreline, which is y is equal to 1, our new midline. At the next 90-degree spot, we're going to go up to 2 because our amplitude is 1. Before I can hit my low, I have to cross the midline, the shoreline, which is at pi. 3 pi over 2 is going to be the next one, which is the low. Don't forget we're doing a sine curve, 0 high, 0 low, and then we're going to finish at 2 pi back at 0. So it's the same exact sine curve that we've been graphing, but the entire curve has been shifted up 1. So notice now that the midline is now at y is equal to 1 because the entire graph got shifted. Not just stretched, but shifted up 1. Do a couple more examples on the next page. This next example has now a change in our amplitude and a change in our vertical shift. So again, let's get in the habit of writing down what we know. Amplitude is 2. Frequency is still 1, which keeps period at 2 pi, which is nice. That helps us out. A little bit less to worry about, 2 pi, but we do have to make sure that we label everything. And again, I'm going to label the y-axis. Every tick mark will be a unit. And what else do I have? So I have amplitude is 2, period is 2 pi, vertical shift is up 2. That means so I have a new midline of y is equal to 2. So I'm going to go back to my graph and very lightly put in the new midline of y is equal to 2. I'm also going to write down the range so that I can double check and make sure that when I'm done with my graph, I certainly am within the range I'm supposed to be. So my amplitude says that without the vertical shift, before the vertical shift, my range would be from -2 to 2. But then with the vertical shift, everything got moved up 2. So that's the vertical shift. So now my graph should only exist from 0 to 4, where 0 is the minimum and 4 is the maximum. All right, so let's graph. It's a sine curve. We start at 0, and our 0 this time is at y is equal to 2. Period is 2 pi, so every pi over 2, every 90 degrees, something significant happens. We have an amplitude of 2, so it means the high is at 4. Our 0 is back down to 2, the midline. Our low is going to be at 0, 2 away. Our amplitude is 2, so 2 away from the midline. And then we're back at the midline at 2 pi. Connect the dots. Nice, smooth curve. Y is equal to 2 sine x plus 2. Double check the range. In fact, yes, indeed, we have a graph that is between 0 and 4 for the y values. Everything looks good. The last one, or the next one, is we have a change. We have a little bit of change of everything. We have a change in amplitude, change in frequency, and a vertical shift. All right, so let's start from the beginning. Amplitude is equal to 3, so that means 3 units away from the midline. Frequency, this person is talking much faster, driving much faster, so it won't take as long to get an entire curve in. So that means the period is now going to be 2 pi divided by 2, which is pi. So that means I'm going to go all the way over here and immediately plot pi. And then from there, go ahead and divide up, divvy up your x-axis into your quarters. This is the key points that I talked about on the previous page. You can jot those down if you want to. If they do help. But if you can do the x-axis without jotting down those key points, that's fine. We have a vertical shift, this time down 2. So that means my new midline is at y is equal to -2. Let's scale label our y-axis. And we need to add -5. We need to add -5 because we're going to be 3 away from our midline, which is now at y equals -2. Before the vertical shift, the range of our graph would have been from -3 to 3, but we shifted everything down 2. So now our range is going to go from -5 to +1. Let's see how that works out on our graph. It's a sine curve. My 0 starts at the midline. My high, 3 units away from the midline, which is at 1, and it's happening at 45 degrees. So at every quarter, something significant happens. After the high, so I haven't done this in a while, 0, high, 0, low, 0, oh, ho, low. After the high, we hit the 0, and then we're going to hit the low at 3 pi over 4, and the low is 3 units away from the midline going down. So it's going to be at -5, and I'm going to finish my graph back at 0, which, yes, I know it's the -2, but it's the shoreline, it's the midline. Notice of all of these graphs have had the same shape. The size has changed, although it's hard to tell, but the size has changed because the x-axis has changed. We've changed the scale on the x-axis. We have one more. This one, the person was talking faster, driving faster. On the next page, we have a frequency of 1/2, and we have a negative out in front. So let's see what happens with our graph here. So the amplitude is now 2. That negative is a reflection over the midline. And the midline is that y is equal to -1. We'll get to that in a minute. So we have the frequency is equal to 1/2. So that means that period is 2 pi divided by 1/2. Keep change flip. We have 4 pi. So I immediately go over here to my x-axis and I plot 4 pi. And the rest of the angles. And if I do my key points, 4 pi divided by 4, notice that every pi something significant is going to happen. So the vertical shift is down 1. Y is equal to -1 is the new midline. Oops, let's scale the y-axis. So when we graph it, we know it's a sine curve, so we know we start at 0. We normally would go 0, high, 0, low, 0. But because of the reflection, we're going to go 0, low, 0, high, 0. So if it helps you to jot it down, so I'm going to reflect it. So instead of going high, I'm going to go low. And I'm going to go low at pi. Pi is my first quarter. And where is my low? Ooh, we should probably jot down the range. That would help us. The amplitude started at -2 to 2. And the entire graph got shifted down 1. So the range is from -3 to 1. So the amplitude is 2. So I am 2 units away from the midline, which is -1. So it means my low is going to be at -3, which corresponds with the range that I just calculated. My minimum is a -3. I'm going to swing back up and hit the shoreline at 2 pi at the next quarter. And then my third quarter, I'm going to be 2 units away from the midline, which is going to be at +1. And then I'm going to finish off at 4 pi back at the midline, which is at y equals -1. So I have a sine curve that was reflected over the midline, y is equal to -1. Not over the x-axis. That's not a very nicely drawn graph. Okay. But it got reflected over the new midline, which is the y is equal to -1. So if you can envision that being reflected over the y equals -1 line, instead of going high, it went low. All right. Before we go on to the next page, we're going to use all this white space just to do a really quick summary of what we learned with the equation, because then in the next page, we're going to go backwards. So in general, when you are given this equation, y is equal to a of b minus c, we should now know what every single number stands for except for one of them. We'll talk about that next class, or in 2 classes. So first of all, the a is the amplitude. And that is the distance from the midline. B is the frequency. Answers the question, how many complete curves or complete cycles within a 360-degree interval. Later, we'll talk about the horizontal shift. You folks know already about the horizontal shift when we talked about it in our transformations unit. We'll talk about that in a couple of days. And then D, this is the vertical shift. This is the new midline. Y is equal to D. And again, midline can either be a raphline or shoreline. You also have to memorize that to get period, you take 2 pi and divide it by b, the frequency. We will also ask you to be able to calculate the range. And usually I say, well, take the amplitude, do negative to positive amplitude, and then plus or minus whatever the vertical shift is. And that'll give you the range. The number on the left will be the smallest y value, and the number on the right will be the highest. So a word problem can ask you what's the lowest, what's the minimum, or what was the maximum height, what was the maximum value. So you're going to be using range to get those values. Feel free to press pause at any time if you need to go back. I am going to keep going to the next section of notes. We have one more page, and like I said, we're going to go backwards this time. This time we're given a graph, and we're going to write the equation. So again, let's jot down. All of our equations are going to be in this format. We are not going to do a horizontal shift, so don't worry about the horizontal shift. We do have to think about 3 things: the amplitude, the frequency, and the vertical shift, and if there's a reflection. So I usually do it, just kind of have an idea, I have a couple of questions that I ask. First of all, is it a sine or is it a cosine curve? Since it starts at the shoreline, it's a sine curve. And since because it's going to be a negative sign, because it goes low, not high. So notice that at pi over 2, it's going down to negative 2 instead of going to positive 2, so that tells me that's going to be a negative sign. We are 2 units away from the midline, so that means the amplitude is equal to 2. I check the end of the curve. I have one complete cycle. It's taken 2 pi. So that means period is equal to 2 pi. I need to find b. I need to find b. And since I know that period is equal to 2 pi divided by b, I'm going to replace period with 2 pi over 1, and set it equal to 2 pi divided by b, and solve for b. This one is pretty easy to do because we can tell that b is equal to 1. In a couple of examples, it may get a little bit, not more difficult, but a little bit longer where we have to find frequency. You can't get frequency just by looking at the graph. You have to set up a really small, a short equation, setting period equal to 2 pi over b, cross multiply to get b. Here, b is equal to 1. Now we're all set to put our equation together. There is no vertical shift. We're staying at 0. So y is equal to, we have a negative because there's a reflection. The amplitude is 2, and it's sine of 1x, which we can just write as x, because period is at 2 pi, so frequency is 1. So y is equal to negative 2 sine x is the equation of this graph. Number 2 on the left-hand corner, left-hand side of your paper. Again, underneath it, we're going to go through what we know and how we're going to come with our conclusions. First of all, because it's starting at 0, it is a sine curve. It is a positive sine curve because we're going up instead of down. We see, since this is labeled 3, this is a 1 and that's a negative 1, so our amplitude is equal to 1. We need to find frequency. We need to find b, the frequency. Well, what I see here is that looks like it's a half of a curve from 0 to 2 pi. So I think if I continue that curve and I go up and I continue my x-axis, I think we can safely calculate that it's going to take all the way up to 4 pi to see the entire sine curve. So if period is equal to 4 pi, and I set 4 pi equal to 2 pi divided by b, I need to cross multiply and find b. So when I cross multiply, it looks like this. It's 4 pi b is equal to 2 pi. Remember, we're solving for b. We're solving for, so I'm going to divide both sides by 4 pi. The 4 pi's cancel. Pi's cancel on this side, so b is equal to 1/2. Where did we just see that 1/2? Oh yeah, that 1/2 was from up here where only half of the curve is visible from 0 to 360. And this is the first time where we actually see the definition of frequency, where frequency is how much of the curve can we see. So the frequency is 1/2. So I now have a is equal to 1, b is equal to 1/2, and there is no vertical shift. So I don't have a plus or minus at the end. So the equation for this graph is y is equal to sine 1/2 x. Y is equal to sine of 1/2 x. That might be a little bit challenging, so if you need to rewind it and listen to that again. Again, the 1/2 here represents that half of the curve is visible, the frequency. We also got the 1/2 by extending out our sine curve, knowing there's a pattern. So if this is 2 pi, this would be 3 pi where it hits the low, and 4 pi would be the end. 4 pi is period. Period is 2 pi divided by b. So I set the two equal to each other, cross multiply, and get that b is 1/2. On the last one, let's replace the 1, 2, 3, 4 on the x-axis with, let's put 2 pi at the end, pi in the middle, half of pi is pi over 2, and then we have 3 pi over 4. That'll make it a little bit easier for us with our angles. So let's look at this graph and figure out what's going on here. First of all, we see that it is a sine curve. I see there's a new midline. See, there's a new midline. So we have a vertical shift. Looks like a down 3. And from there, we can calculate amplitude. Notice that our high is at -1, our low is at -5. How many away from -3 is that? That's going to be 2. So the amplitude is 2. It's a positive sine curve because we're going up instead of down. And now we have to find b again. So number 4, we need to find b. And when we look at the graph, how long does it take for one complete cycle to occur? I'm going to highlight it. One complete sine curve only takes pi. So period is equal to pi. Period is equal to pi. Period is 2 pi divided by b. We're going to cross multiply. So we have pi times b is equal to 2 pi. Divide both sides by pi. And notice that b is equal to 2. And I would like for you to be able to see that since frequency is 2, I'm going to change my highlighter color to purple. And note I'm going to highlight the two curves between 0 and 2 pi. So here's one sine curve, and here's the second sine curve. So the frequency 2 answers the question, how many curves are there between 0 and 2 pi within any 360-degree interval, and there are 2 curves. So if you could have seen that, instead of setting equal to 2 pi divided by b, you can do that. You just want to be careful with how many curves you have and counting them. I like the algebraic method here of finding the b value of 2. So I think we're all ready to write an equation for this graph. Y is equal to, I have to think now. All right, I have an amplitude. Yep, I have an amplitude of 2, and it's a sine curve. My frequency did change. I have 2 curves within a 360-degree interval. I'm going to put that inside parentheses because I want to keep the vertical shift outside. I don't want it to confuse it with a horizontal shift. It got shifted down 3. So y equals 2 sine 2x minus 3 is the equation of this graph. You folks have a day 5 classwork that goes along with these notes. I will have answers posted on Classroom, and I will talk your way, I think I'll try to talk the way through that one to show you how the answers work out. Please work on the day 5 homework, and probably the next couple of days I will have that posted and we'll go over that as well. I will try to continue to post videos online. I'm not sure how regularly we can get to do that. Good luck. Again, I will post other links. Use your resources, use your friends. email me. I will, if I'm going to be at my computer, I will let you know ahead of time at what time so we can do a Google Hangout chat. Like I said, I'll try to get Zoom ready. If you have any ideas or if anything works for other classes that you're doing, please let me know. We'll get through this. We'll get through this together. Go back and forth between Trig and your Regents Review, and just keep checking Classroom, keep checking your email for more communication from me. Believe it or not, I do miss you all. Hope all is well. Bye.